Alright, so let's quickly have a talk about how these parts were designed and made. We'll start out with the control panel. The control panel is very straightforward. I just used a laser cutter and some trial and error, I guess, to find, convenient spacings for all these components. One thing you've got to keep in mind, especially with potentiometers, which is what the adjustment knob here is that there's a lot more space taken up behind the component. So you have to account for that. You have to make sure that'll fit with a switch there. Yeah, this is 304 stainless steel. It came out of a pre-polished sheet, so that's why it looks so nice. If I'm being totally honest, I water jet this part. So we have a water jet cutter at my work. Blasted this thing out in like, I don't know, 2 minutes, a minute and a half. I maintain that you can manually machine all of these components. I water jetted this one out because it was faster and I was sort of hurting for time. I had to get the parts finished for the weekend, but you could certainly cut this out manually. You'd use either a jeweler's saw or maybe a scroll saw, and you can cut stainless steel with that. And then you can just drill the holes the old-fashioned way. You'd want to do the layout and the markup on the back side, and then it would just be a matter of cleaning it up with a file, probably. So like I said in the previous video, there's no method of retaining the screen, so I might have to do a bezel. I'm not sure what that would look like yet. If I'm lucky, I might be able to spot weld something on the front here that'll stop it from coming out the front, and then maybe have some kind of a preload system in the back. I'm shuddering at the thought, but I may just epoxy it in place, only if it looks good though. One thing, if you were going to water jet this as well, you want the bad side facing up. That's because when the water jet starts to pierce through, it'll shoot the garnet everywhere, and that's what these big V marks are. And then once it breaks through, it's fine. So the other side comes out looking perfect. The side that's facing up gets a little messed up. This is the pivot. It's made out of an aluminum bronze. Like I mentioned in the last video, I basically just whittled out this part here. So that's not a perfect semicircle, but it works perfectly well. One thing I try to do when I design semicircular features on turned parts is to make them 6 millimeters in diameter. That way you can use standard circular inserts. Didn't do that here, so had to whittle it out. For this part, I basically turned this side of it first. I had a little extra material in the chuck, and then I had to make this the correct diameter as well. You can see on the bottom of the tool post, there's actually a surface for it to mate on. I wanted a little bit of clearance. So if you can imagine this cut in a cross section, now you don't have to imagine it, I'll show it. You can see that because there's this shoulder here, I'm not anticipating a whole bunch of chips getting up in there, and I think that'll protect the joint a little bit. After I turned this shoulder component, I flipped it around and tapped a hole and faced off the back. Now, like I tend to do with sort of post-shaped things, I relieve the inside of it, and that's just because I want a nice, firm seating around the outside. So this attaches to the, I don't know, cross slide, I guess, with a flathead screw. There. So that's how that fits together. The tool post itself is a bit more of a complex part. Like I mentioned in the last video, it's made out of 17-4 stainless, which is just amazing to cut. I love cutting it. It's short chipping if you cut it properly. I didn't have a whole lot of material to play with on this. It's 1.25 inches, and I had to get it down to 30 millimeters, and I wanted it to be on size, so I took some pretty shallow cuts, hence the chip breaker wasn't working, so the chips were pretty stringy. You normally wouldn't get that out of 17-4 though. When I'm making a part like this, I like to sort of imagine the machining operations first. So this part only works if the bore is correct and if the shoulder is correct, so I decided to do those first. That's if you can nail the important stuff first, then it's a little less stressful when you do the less important stuff later on, I find. So I did the bore on the lathe and the OD, and then I actually marked off the length on the lathe as well, and then I came in and did a chamfer with the back of a right-hand turning tool. From there, I chamfered the inside of the bores. I did that using a small TNMG insert. The insert itself is made for aluminum. It's one of those high polish ones. They work amazingly. I love them. They work really well in stainless steel too. You've just got to be really careful because they're extremely delicate. So they're good for something like chamfering. Well, I might hear this upstairs. Not bad. Once I was done with that, I put it in the mill and I cut this slot here. So this slot is where the tool goes. First thing I did is I knocked this off to be a D shape, and then I came in with a 1/4" end mill and did the slot. I tapped the holes while I was set up there, and then I had to drill this sort of tangential hole. And the tangential hole I had to start out doing with an end mill because obviously it's off center on a cylinder and it would want to wander. After that was done, I turned it on its side and I just basically located it off the D shape using a square. And then I was able to drill the M6 hole in the back. From there, I flipped it up again, and that was to do the relief for the pin head. In hindsight, I would have used a sharper end mill, and I probably would have worked on my feeds and speeds a little better. As you can see, the inside is actually kind of chowdered up a bit. Fortunately, this will be covered by the head of the pin, but you can definitely see in the footage the end mill is kind of wandering around. So as I mentioned in the previous video, that just goes together like that. You can see through here where the pin goes. One thing I was thinking of for a locking mechanism is actually having a pin on here that's got an eccentric section, and then I could turn the pin, that would push into this rounded out section, and that would lock it in place. There's a lot of more rigid designs out there, especially for tool posts. The lathe is a very old machine tool, so naturally tool posts are very well developed. One thing you'll often see is being attached from the center, and it'll be held down onto some kind of spline or a taper, or just held rigidly in place against a flat surface. I didn't want to do that because I wanted my tool to be on center line, because then I can sort of predict my radii a little better. If the tool is off center line, it'll still cut a radius, but it'll be cutting with a weird part of the tip, so I wasn't sure I wanted to do that. One thing I'm thinking of doing is actually knocking a semicircle out of the front of the tool post. That way I can move the tool further back and I can cut really small radii. I don't really have a great plan for cutting external radii, except maybe I'll make a different tool for that at some point. Finally, we can talk about machining the handles. So the first thing I did is I basically cut my stock to length, and then I cleaned up all the sides. I drilled the ends before I did any of the fancy bevel work. The first bevels I did were actually these bevels here. In hindsight, that wasn't a great decision because I could have used this edge to line up for the second bevels, but I did, so I had to find a way to line up for the secondary bevels, and I did. You'll see in the footage. Secondary bevels, I had this in a toolmaker's vise, and I actually tilted it a little bit, and I put the toolmaker's vise inside of a larger vise, and I used that for machining away these compound angles. You'll notice in the footage that the small toolmaker's vise isn't really gripped very strongly. Not a lot of material is being held. If I was doing any kind of rough cutting, that definitely wouldn't be good enough, but this was actually very gentle cutting. I basically scribed this out beforehand, and I just cut up to the scribe line. You can still kind of see a scribe line on one of these. That's unfortunate. I think I got a pretty good handle on making these. After tumbling, I sent them out for anodizing. I get a lot of my parts anodized. My work gets a lot of parts anodized in black, so it's basically nothing for me to just throw my parts in. I still pay for them, but the setup fee is basically covered, and adding additional parts to that is very inexpensive. And even if that weren't the case, I dabbled with home anodizing before. I got some mixed results, but it was a pretty big pain in the butt. And anodizing, the setup cost is about $100 probably for a job you're doing yourself. And then past that, it's quite minimal per part. So you can imagine if I was getting the entire machine anodized myself, I would wait till the end and do it all in one batch. And I'm sure it wouldn't be that expensive, and it's a really professional job. So it seems like a win-win. Alright guys, well that's it for the machining component of this part of the jeweler's lathe video. Thanks a lot for watching. Thanks a lot for the feedback I've gotten so far in part 1 of the video. Cheers!